Hi, I'm Tarik Rashid. Today, the title of this tutorial is GOOSE, which is an algorithm, and I'm going to explain this algorithm step by step. And it's a tutorial so that you can understand algorithm mathematically, how it works, and how you can execute them in your MATLAB. So, without further ado, these are the links when you want to download more information about the goose. The paper itself, it's there. And if you have any question, feel free to email me in this email. Let me go through the presentation momentarily. The GOOSE algorithm, it is a new algorithm recently found by Reb Khalid and myself, Tarik Rashid. And it's a unique metaheuristic algorithm. It is based on how goose can behave when they are at rest and while they are foraging. So the goose balances and stands out on one leg to observe and defend on the other birds in the flock. So one main goose, as a leader, puts stone on its leg and observes and defends the rest of the geese in the flock. So basically, method starts by searching space, and randomly we take a sample from the population, and then we go through fitness function of each one of them, and we select the minimum fitness or the minimum value for the agent or goose. So this is the algorithm: start population, and then compute object function for each goose, and then there's a random value. If yes, then goes this way, and there's also weight of the stone. If yes, if greater than 12 and equal, then go this way. Execute equation 9. And if no, then you go leftmost and you execute equation 13, 11, and we'll come to them one by one through our case study. So this is the algorithm in detail, and it's in the paper. You can go and check each equation by yourself, and I also explain them in my case study in this presentation. So the goose, it has two phases: exploitation, local search; exploration, which is the flock of geese. They do exploration, local search, global search, sorry. Again, there's also an idea of distance of sound trouble in the air. So sender and receiver. So when the sound goes to the object and it comes back, so that's the analogy of the distance of sound travel in the air. Now, the case study, we have fx equals x1 square plus x2 square, and x ranges greater equals 0, less than equal 10 for x1, and for x2, same range. Now, step number 1, we randomly select a sample of in the population, and we assume it 5 agents, each one of them represented by a goose. That's the table: 5 geese, 1, 2, 3, 4, 5. Each one of them has 2 dimension, x1, x2. Square them, and from them, then you get the fitness. So in this first iteration, we have the first agent, first goose, has the best value, 30. Now, after running, we will also consider that we had the best score 13 and the worst score 181, and then the best score position 3 by 2. And then we have also some parameters: probability, rand, and coefficient for moderating the equation, and dimension 1 and 2, x1 and x2, and this speed sound, which is 343.2, that's a constant. Remember this value. And then mt is the infinity at the beginning. And with the iteration, this mt will get reduced. Now, finding the weight stone that the goose stands on its own feet, 1 feet, and it puts stone on the other one. If stone falls, then it makes sounds, and this sound goes in the air to other geese in the flock, and then they'll get alerted, and they will be vigilant if there's any danger. That's the idea. So weight of the sound can be found by this equation, and it has to be in between 5 and 25, and we assume that we found the value randomly 12, and then we will find the time of arrival of an object to the ground, time of arrival of the object to the ground, and this is for 5 goose number 1, 2, 3, 4, 5, and through this equation we found these values. And then we have another time, sound time arrival to the group of the geese. So when the stone falls, then the sound will go to the group of the flock of geese. So, and these are the values, and we found it through the equation 3. So these are the values. Now we will find the summation of these time arrival of sound to the groups. We've summed them all up, divided by dimension, x1 and x2. So it's 2, number 2, divided by 2. And then we further divided by 2 for mathematical convenience, because we need to have time A as less as possible. Okay. Now, updating the agent 1 positions, x1 and x2, we have to update them. So we have these conditions. For example, randomly we selected greater than 0.5, if it's greater than 0.2, and weight of stone greater than, then we follow equation 6, which is the free fall speed, which is the force for the stone, to be found by the time arrival of the object to the ground multiplied by square root of the weight of the stone divided by the gravity, and we find for the first agent 2 values, x1 and x2. Then we will have to compute distance of the sound travel in the air, which is distance sounds travel to the air, which is equal to sound speed. We said that this is constant, 343.2, and then multiply by time of arrival of sound to the group, okay, to the group, and then we found it. Then we have to find the distance of each goose from the leader. We need half of this distance. So because there is sound going one way and coming back, so we need half of it. That's why we multiplied by half and multiply by distance of sound travel in the air. So these are the values that found for the goose, for the agent number 1, or for the first agent we call it. Then we have to update the position of first agent, which we found the force value or fall value, and then plus the distance of the goose from the leader multiplied by the time square, the average time square, and we found it. This is the updated value for first goose. Now, then we have to do it for the second value. Of course, we get different random numbers so that we can check all scenarios or all equations that we have. Now, this time around, we changed the condition a little bit, assuming that we receive different random numbers. Then we follow equation 10, okay, because now less than 0.02 or equal and less than 12 the sound. So here the time time arrival of the object to the ground will be found this way, and we have it and multiply by weight of the stone, then we get the force value, okay, which is free fall speed. Then we will do for next step, we will find the uh, uh, distance travel, distance of the sound travel. Again, we will have sound speed multiplied by time arrival of the sound to all group. We multiply, and then we'll find here in equation 9, through that we will find the distance of a goose, second goose, from the main leader, from the main goose. And then this is how we update uh, the value according to the conditions that we have, those parameters. So this is finding the positions of the second goose for the next iteration. Now, here for the position tree, for agent tree, and we have to update x1 and x2, the current value 6 and for x1 and 5 for x2. Then having these conditions, for example, randomly these values, then we go to equation 6. As usual, this one repeated. We'll find the free fall speed, okay? And then after that, we will find the distance of sound travel by having the sound speed value multiplied by speed of the sound travel to the group. Then we got the value, and then we have to find the position or the distance of the goose tree from the main leader multiplied by half, because we need half distance, and we found it as the distance for the third group. Likewise, we have to update this value. Actually, this is if I say this is just iteration, next iteration, which is iteration IT plus 1, next iteration. So it just same thing. We will have the force value multiplied by the distance of the goose from the main leader multiplied by average of the time multiplied by coefficient, and that's how we found it. Then we will do it for the fourth agent, similarly with these conditions, with the equation 6, we found it, and then we find distance travel, distance of the sound travel in the air. That's how we found it, and then this is the distance of the fourth agent from the main leader. Now, this is how we update the value. Again, that's the how update value, which is using equation 11. That's how it's done. And then we will have the final agent. We have to update its position. Here, based on the condition rand less than 0.5, then we select equation 12 to find alpha. Alpha can be changed in every single iteration using this equation 12. A loop means first iteration is 1, second iteration loop will be 2, third iteration will be 3, and so on and so forth. And max iteration is constant, 500 for every time we run the algorithm, over 2. So 1 divided by 500 over 2, 1 over 250, and alpha found 2. That's how we found alpha. Finding alpha, we use it in the equation 13 to find the position of the agent 5. Okay, and these are the best positions that we have in this iteration. Random n, and then you have agent 5 new position, which is 3.67 and 2.67. Now, this is the table that we have, and it's updated now. Then we go to next iteration, second iteration. Then these are the values. And we found that in the uh, second iteration, this value is got worse, but then still we have the minimum is 2. Agent 2 is the best score or the best position we have. It has 0.31 and 0.14. That's the X1, X2, and that's the fitness 0.12. It's the best. Now, having said that, each iteration, the random values are changed. We change random values and we follow similar equations according to the conditions that we have. We will find weight sound and then travel of object to the ground and then travel of the sound in the air to the group, and then we will find the sum of the time and average time, which is reduced, and then we update every single agent's position by finding the free fall speed and by finding the distance of the sound travel in the air and by finding the distance of each goose from the main leader. So we do this one for each agent and we update its position through equation 9 in this case. And then we'll do it for agent 2. That's done for agent 2 as well. And then we do it for agent this 2 again, still working. And then agent 3, it also can be done with these conditions. And it is continues as it is. And then agent 4, that's for agent 4. And then that's for agent 4. Again, we will find the updated version for agent 4, these 2 versions. And see, the values are reduced. That's minimization. That's the optimization in terms of minimization. Now, this is the 5th position. Again, we selected equation 12 based on the condition that we have round less than 0.12, 0.5, and then we found that alpha is this much, and then we found that agent 5, which is not the best, 0.37. Then the table is updated, and I think this is the maybe agent 4 is the best, and you can see the minimum value it has. So in this iteration, agent 4 is the best. So thank you very much for this short step-by-step tutorial for GOOSE algorithm. If you have any problem, the GOOSE algorithm PDF file for the paper, main paper, is there, and my email is this one. Thank you very much, and see you next time, or talk to you next time. Thank you.